In this video, we present attribute gates. Attribute gates are interface elements designed to be used with digital tabletops using pen-based or finger-based input. They allow a sequence of attributes to be set in one fluid operation. The unique characteristics of tabletops make them different from traditional desktop computers. Standard point-and-click interface components designed for desktop computers are not necessarily suitable for tabletops. Using a contextual menu, for example, to set a group of attributes, requires the user to perform a number of point-and-click subtasks. This shifts the user's attention from the original task. Standard user interface components were originally designed to be used with the mouse. Pen input differs because it encourages a fluid, stroke-based style of interaction, hence it is more suited to crossing-based interfaces than point-and-click. With a crossing-based interface, an attribute is usually represented by a thin rectangular area and is set by crossing it. Positioning attributes appropriately allows users to set a number of them in one fluid stroke. Attribute gates use the crossing-based concept to solve a specific tabletop interaction problem. When people collaborate around a tabletop, the surface is typically divided into personal, public, and storage spaces. Each space places different requirements on its objects in terms of scale, orientation, and access right attributes. It's important to have lightweight techniques to change these attributes because in many cases, users need to override the system's defaults. Since changing the attributes is usually required when moving objects between spaces, integrating the operations for changing the attributes with the movement operation has been one of our main design goals. This integration keeps the user focused on the main task at hand. Another design goal of the attribute gates is to make the actions being taken more visible to others, and hence to improve the overall awareness. We designed two types of attribute gates, grid and polar. Grid gates have each set of mutually exclusive attributes placed in a row. The user makes the gates visible by a press and hold operation, then the user changes the settings by crossing the required gates while moving the document to its final destination. Polar gates have each set of mutually exclusive attributes placed in a ring. Users change the settings by crossing to a certain gate, rotating the ring, and crossing to the next. Polar gates remember the most recent configuration. This allows the user to repeat the setting by moving in a straight line towards the destination. We designed the spatial layout of the gates based on steering and targeting laws to make setting the attributes and steering between them as fluid as possible. We've run a number of trials to compare the performance while setting a sequence of attributes using standard contextual menus, grid gates, and polar gates. We've measured the time for setting the attributes, the error rate, and awareness. Attribute gates showed a clear improvement in terms of time and awareness as compared with contextual menus. Grid and polar gates performed equally well, with grids being faster in general, except for repeated settings because of the polar gate's memory feature. From the trials, it was evident that the gates do satisfy their main design goals of being lightweight interface components, as well as improving mutual awareness.